This class is designed to help the student of class 10 and I am continuing the chapter force. And in this chapter force, today's focus is on the weight and the variation of weight in different parts of the earth and the factors which affects the weight of the body. Now let's start with the definition weight. Look at this. First I want to give you definition. In previous class also I told you that the force of attraction of the earth acting on a body is the weight of that body. Means, just for example, this marker pen is attracted by the earth and the force with which earth attracts this marker pen towards its center is the weight of this marker pen. This is the normal definition of force. But there is another definition also for the force. This definition can be told as definition in terms of measurement. According to this, weight of a body, we can define force this way also. Weight of a body is the product of its mass and acceleration due to gravity. What is the meaning of this? If you know the mass of a body, then with the help of the value of g, you can calculate the weight of that body. If mass of a body is 2 kg, then we know that g is 9.8 meter per second square. This is the average value of the g. And that's why 19.6 is kg meter per second square Newton. This way we can calculate the weight. That's why looking at this equation, we can say that there are two factors which affects the weight of the body. One is the mass of the body, another acceleration due to gravity of that place. Now there are some questions related to this. Look at this first question. Weight of a big stone is greater than a small stone. Why? If we have two stones, one is big, another is small, then mass of big stone is greater than the small stone. And weight of a body is the product of its mass and acceleration due to gravity. That's why the product of mass and acceleration due to gravity in case of big stone is greater than small stone. That's why a big stone weighs greater than a small stone. Now I want to talk about the weight of the body which alters due to the value of g. There are some region questions which are frequently coming in examination. I want to talk about them. Look at this. Weight of a body is more at pole than the equator. Why? Now we can answer this question this way. First you have to say that weight of a body is the product of its mass and acceleration due to gravity, and then you can write W equal to mg. And then you can say that mass of a body remains same at pole and equator, but g is inversely proportional to square of the radius of the earth, and you can write this mathematical notation also. Since earth is flattened at pole, bulge at the equator, radius is less at pole, and that's why g is more at pole, but because of greater radius, g is less at equator. So the product of g and mass of the body, that is the weight, is greater at pole, hence it is greater at pole and less at equator. This way we can answer this question. Now next question, look at this. Weight of a body is less at the top of the mountain than the bottom. This can also be answered in the same way. First you write the definition of weight in terms of measurement this way. Weight of a body is the product of its mass and acceleration due to gravity, and then write down W equal to mg. Mass remains same at the top and bottom of the mountain, but g is inversely proportional to the square of the radius of the earth. The radius of the earth at the top of the mountain is more than the bottom of the mountain. That's why g is less at the top of the mountain, and the product of g and mass of the body, that is weight, is also less at the top of the mountain. This way we can answer. Now next, look at this. Weight varies from place to place of the earth. How to answer this question? This also, we are starting with the same thing. What? Weight of a body is the product of its mass and acceleration due to gravity. Mass of the body remains same throughout the earth, at any place of the earth. But earth is not a sphere. It is flattened at pole, bulge at equator. That's why its radius is different in different places. Where the radius is less, g will be more, and where the radius is more, g will be less. So the product of mass and g, that is the weight, becomes different in different parts of the earth. This way we can answer this question. Now let's talk about another point, another definition: free fall. What it means, free fall? Acceleration produced on a freely falling body due to the gravity of the earth is acceleration due to gravity. Like this, I told this in previous class. I want to show this again. If a body is dropped from certain height, at first its velocity will be 0. At the end of 1 second, its velocity will be 9.8 meter per second. At the end of another 1 second, 19.6 meter per second. At the end of another 1 second, 29.4 meter per second, and so on. This way, acceleration produces on the body. A body is said to be in free fall if it falls with acceleration due to gravity, like this, without any resistance. This is definition. What? A body is said to be in free fall if it falls with acceleration due to gravity, like this, without any resistance. Means we do not consider air resistance also, or there must not be air resistance also. This is the free fall, and it is possible only in vacuum. Now next point, weightlessness. What is it? Weightlessness. Weight of a freely falling body is 0. Weight of freely falling body is 0 due to the lack of reaction force. Such a condition is called weightlessness. Now, how to understand this clearly? Look at this. We measure weight with the help of what? Spring balance. This is roughly, this is spring balance. And if you want to measure the weight of a body, then you will use spring balance. And this is the body. Exactly what we are doing at this time. We want to know with what force earth attracts this body towards its center. Because the force with which earth attracts a body towards its center is the weight of that body. That's why we are measuring the force of attraction of the earth acting on this body. But how do we measure this? When we suspend it with the help of this spring balance, then the spring balance creates another force, that is called reaction force, to hold this body. I mean to say, with what force earth attracts it towards its center, with the same force the spring balance holds it. And the reaction force is used to neutralize the force of attraction of the earth. And that's why weight is measured in terms of this reaction force. But in case of freely falling body, there is no reaction force. That's why when a body is in free fall, it becomes weightless due to the lack of reaction force. Such a condition is called weightlessness. Students, now I think more or less I finished this chapter, but one of the students asked me one question related to the chapter pressure, and he was interested to know about the numerical problem related to principle of flotation. I want to tell him very clearly. Look at this. I think he want to know this numerical problem in which a liquid is taken, let's say water, and certain object which floats in liquid, let's say this is ice, and maybe density of ice may be given, or maybe volume of the ice may be given, and density of water may be given, and how much part of this ice is immersed in this water, or how much part is outside the water may be the question. But this question is out of syllabus. I want to inform you that there are many things which are removed from the syllabus, but because of certain reason it is again taught in classes. Just like other I want to mention, in the chapter, energy chapter also, you don't have to write nuclear reaction, like protium when combines with another protium, then deuterium forms. This type of notation of nuclear reaction is removed from the syllabus. In the same way, Faraday's law of electromagnetic induction is also removed. All these parts are removed, but because of certain books which is not revised by the book writer, and it is published, and the same books are taught in school, it is taken in the school, and teacher has to teach that syllabus, and teacher are teaching those syllabus because the book is given to them. But these parts are out of syllabus. You don't have to prepare this, and you must know before the SEE examination, at least you focus on the syllabus which is necessary for SEE examination. That's why I wrote this book. And if this is not the textbook, this is the revision of all the part of your science syllabus. Everything is given in the form of question answer as far as possible. If you get it as far as possible, you try to learn it, and it is enough. And out of syllabus, this is not the time to go through out of syllabus. This much for today. Thank you.